Today we're looking at perpendicular and parallel lines on the Cartesian plane. So basically, if two lines are parallel on the Cartesian plane, what that means is that they actually have the same gradient. So they're at the same slope or steepness. So we would write this as m1, so the gradient of the first line, is equal to m2, the gradient of the second line. So that's really quite nice and straightforward. Um, if two lines are perpendicular, on the other hand, their gradients are what we call negative reciprocals. Now, this is a little bit more confusing, but what it means is that the gradient of the second line is equal to -1 over the gradient of the first line. Or we can also write it that the gradient of the first line multiplied by the gradient of the second line is equal to -1. So I'll just take you through a couple of examples today using points and equations rather than visually looking at the Cartesian plane. So our first example wants us to find the equation of the line that's parallel to y is equal to 3x minus 1 and also passes through the point 0, 4. Now it's really important to remember we're still using our gradient intercept form. So that's where we read our gradient and our y-intercept straight off the equation. So if this line y equals 3x minus 1, we can see straight off the bat its gradient is 3 and it crosses the y-axis at -1. Now, what's important from that equation is our gradient. So our gradient is going to be 3 on our other line as well, and our other line passes through 0, 4. Now, because x is 0, that tells us that 4 is the y-intercept. So it's really a nice straightforward example. So we know m equals 3, c equals 4, so that our equation must be 3x plus 4. But then for our second example, we're looking at perpendicular lines. Now that's a little bit more, there's a little bit more to that. So if the line that is perpendicular to the one we want to look at is y is 2x minus 3, that passes through 0, -1. So we want to first work out the gradient. Now, it's not as easy as a parallel line where we simply read the gradient off the other equation. We know that if the gradient of this line is equal to 2, then the gradient of the other line must be equal to -1 over 2. So that tells us that the gradient of the line we're looking for is -1 over 2. And of course, again, the line passes through the point 0, -1. Because x is 0, -1 is the y-intercept, so c is -1. Putting that into gradient intercept form, we get our equation of y is equal to -1 over 2x minus 1.